Now, when we're doing our calculations, we had talked about an approximation for enthalpy earlier. What we want to be able to do is we want to be able to express enthalpy in terms of enthalpy per kilogram of dry air. So let's take a look at that. Given that for typical HVAC applications, the mass of the air, the dry air that is, does not necessarily change. Usually what we're doing is we're either adding water vapor or we're taking it away. So the mass of the water is changing, but the mass of the air is not changing. And consequently, we quite often will non-dimensionalize things per kilogram dry air. So that's what we're going to look at now. So there we have the two components, the dry air as well as the water vapor. We want to non-dimensionalize or divide, I should say, by the mass of the dry air. And this term here we just saw when we were talking about specific humidity. So that becomes an expression that we can use to evaluate enthalpy, and that would then be per kilogram of dry air. Now, oftentimes we're looking at enthalpy change for some sort of process, whether we're removing moisture or adding moisture, anything like that. So let's take a look at how we would handle an enthalpy change. So we can treat these two different terms differently. First of all, we have that one. The first one is for the dry air, and the second one is for the water vapor, and it has the specific humidity integrated in there. So if we look at our earlier expression that we had for the enthalpy for dry air, we can write that out here. Once we get that, notice enthalpy at 0 degrees C, that's going to cancel out. And we get that for our expression. Now for the second term that we have here, notice that the specific humidity at 2 does not equal the specific humidity at 1. We need to retain the full term, given that the enthalpy at 0 degrees C, we said was 2501.3 or something of that order. It might vary depending upon the book that you're using. But given that, we can't make the cancellation that we had in the first term and cancel out the enthalpy there because the specific humidity value between 2 and 1 will change. But anyways, that gives us an approximation for calculating enthalpy change per kilogram mass of dry air.